Hey folks, it's Steve here. I'm here to talk about why assumptions matter when developing software, especially with object-oriented development. Let's get into it. Have you ever built something awesome with building blocks? Maybe a tall tower or a complex structure that made you feel proud? You can use them to make all sorts of things: cars, castles, even robots. The possibilities are endless when you have the right pieces and a bit of imagination. In computer science, we use something similar called objects to build programs. These objects are the fundamental building blocks of our code. Object-oriented programming, or OOP for short, is a way of writing code that's organized around these objects. It helps us structure our programs in a more logical and efficient way. Each object is like a mini program with its own data and actions. These objects interact with each other to perform complex tasks. Think of it like a car. A car is a complex machine made up of many parts working together. A car object would have data like its color, speed, and fuel level. These pieces of data define the state of the car. It would also have actions like accelerate, brake, and turn. These actions define what the car can do. OOP lets us group these related pieces of information and actions together, making our code neater and easier to manage. This organization is crucial for building complex software systems. Just like how organizing your building blocks by color or size can help you build faster, OOP helps us build better software. It makes our code more modular, reusable, and easier to understand. Now imagine you're part of a team building a giant robot with building blocks. Each of you is responsible for a different part: the head, the arms, the legs, and so on. To work together effectively, you need to make some assumptions. You assume that the person building the head knows how to make it turn. You assume that the leg builders will ensure the robot can stand. These assumptions are crucial in OOP too. When you're writing code for the car object, you don't want to worry about how the engine object works internally. You assume that the engine object will handle starting and stopping when you tell it to. This is like trusting your teammate to build a working head without micromanaging every block they place. This idea of making assumptions and trusting other parts of the code is closely tied to abstraction. Abstraction allows us to focus on what a piece of code does rather than how it does it. Abstraction is like using a remote control. You don't need to understand the inner workings of the remote to use it effectively. You press a button to change the channel, and you don't need to know how the remote sends signals to the TV or how the TV actually changes the channel. The complexity is hidden from you. In OOP, abstraction means we only need to know what an object does, not how it does it. This allows us to use objects without needing to understand their internal workings. This is similar to how we use many everyday objects. Going back to our car example, you don't need to know the intricate details of how the engine works to drive the car. You just need to know the basic controls. You just need to know that pressing the gas pedal makes it go faster. The rest is taken care of by the car's internal systems. Abstraction simplifies things, allowing us to build more complex systems because we don't get bogged down in the nitty-gritty details of every single part. This way, we can focus on higher level problem solving and innovation. Section 4. Trusting your team. Objects working together. Think about what would happen if you didn't trust your fellow robot building teammates. You might start building backup legs just in case they mess up. This would be a waste of time and blocks. Similarly, in OOP, if you don't trust that other objects will do their jobs correctly, you might end up writing redundant code. This makes your program less efficient and harder to maintain. Trusting your code teammates is essential for building robust and well-organized software. Just like a well-coordinated team can achieve amazing things, objects in OOP work together seamlessly because they rely on each other's functionality. This collaboration makes it possible to create complex and powerful programs. So, the next time you write a piece of code, remember the importance of assumptions. They are the silent agreements that make our code functional and efficient. They are not just guesses, they are the building blocks of trust and efficiency in object-oriented programming, just like they are in our everyday lives. Without these assumptions, our code would be chaotic and unreliable. Similarly, in the world of software, Assumptions and trust are the foundation upon which complex and reliable programs are built. These assumptions allow developers to create intricate systems that work seamlessly together. When you use a coffee maker, you assume it will heat the water to the right temperature. This simple assumption makes your morning routine smooth and predictable. These assumptions are based on the trust we place in the manufacturers and engineers who designed and built these everyday objects. We rely on their expertise to ensure our gadgets work as expected. Section 5. Real-world assumptions, from cars to coffee makers. This section explores how assumptions shape our interactions with everyday technology. Assumptions are everywhere in the real world, not just in coding. They are the unseen threads that hold our daily experiences together. When you drive a car, you assume that the brakes will work when you press the pedal. This trust in the car's design and engineering ensures your safety on the road. As we look to the future of coding, the importance of assumptions will only grow. In a world where technology is becoming more interconnected and complex, the assumptions we make as developers will continue to be the foundation of innovation and reliability. As artificial intelligence and machine learning advance, these assumptions will help us create smarter, more intuitive systems. Imagine a world where your smart home not only follows your commands, but anticipates your needs. This future relies on the careful assumptions coded into every device, ensuring they work together seamlessly. As developers, our responsibility is to make these assumptions clear and robust, paving the way for a more efficient and harmonious technological landscape. So, as you continue your journey in coding, remember that every line of code you write, every object you create, and every system you design is built on a foundation of assumptions. Embrace them, refine them, and let them guide you towards creating the next generation of technology. Thank you for watching. Don't forget to like, subscribe, and hit the notification bell for more insights into the world of programming.